Hello everyone, this is Michelle Long. Welcome to Math 111, Pre-Algebra Skills for College Success. In this podcast, we're going to focus on Chapter 5, and this is going to review the first two homework assignments that you have for Chapter 5, which is Operations with Fractional Expressions. This chapter happens to be probably the most complex and most difficult for just about a majority of my students since I've been teaching this course. So I decided to do a podcast on this entire chapter. This particular podcast only focuses on the first two sections. The first section is 5.1, and that is multiplying and dividing fractional expressions. And it also coincides with the homework assignment that I gave you for 5.1, which is multiplying and dividing fractional expressions. If you're working on that exercise and you come across some questions that you find more complex, what I'm going to do is I'm going to give you some examples in this podcast. I'm not actually going to give you the examples in the exercise because I want you to work those out and show me as much work as you can. A lot of you are sending me your work, which is great, but I need to see your work and how you came to your answer. So please follow along in this podcast, and it will definitely help you complete the questions in this assignment. Okay, so the rule for multiplying of fractions and is probably the easiest thing that you can do with fractions. There's no flipping of any fractions. There's no borrowing or trying to find common denominators of any kind. It's basically just you're multiplying the numerator times the numerator. You're multiplying the denominator times the denominator, and that's it. That is all you need to do with multiplying fractions. Whenever you see the word of in multiplication in mathematics, it always means multiplication. So in this question here where it's asking you find 5/8 of 2/3, it always means multiplication. So you're going to replace that word of with a multiplication symbol. And you're basically just going to set it up as a multiplication of fractions by saying 5/8 times 2/3. We're going to take the 5, we're going to multiply it by 2, we're going to take the 8, we're going to multiply it by 3. Okay. Now, the trick is in multiplying fractions is when you get your answer. When you get your answer, you then have to break down the fraction into simplest form. We're at a point now in this course where you should know how to break a fraction down to the simplest form because I taught you that in the podcast in the last chapter, and it basically means just taking a fraction and breaking it down until it can't be broken down anymore. Some people do it in a few different ways. It depends on the way that you've learned it, but I can show you some of the ways that are easy for you to break down fractions in this podcast. But basically 5 times 2 is 10, 8 times 3 is 24. 10/24 is your answer. So what they've done is they've actually done the prime factorization method. I strongly advise, and I'm going to say this for 5.2 also, I strongly advise before we start 5.2 that you watch the video for prime factorization. Please know what that means, and please know how to do it, because you're going to need to know that before moving on to section 5.2. So prime factorization is taking a number and you're factoring it out until it reaches its primes. So I'll talk a little bit more about that in the next section, but please watch that video before the next section. So stop this when you can and watch that and then come back to this podcast. On the bottom we have 8 times 3. So 8 prime factored out is 4 times 2, and then 3 is just itself is 3. So 4 times 2 times 3. So whenever we have a common factor in both the numerator and the denominator, we can cancel it out. So we canceled out the 2 because 2/2 is actually 1. We're left with 5 times 1 and 4 times 1 times 3, which is 12. So we've basically just took the answer and then reduced it to 5/12, which is the simplest form. We can't go any further than 5/12. Here are some more examples that we did for multiplying fractions, and this one here we have 8 over 15 times 12 over 14. We're taking the 8 and we're timesing that by 12 because remember we just multiplied the numerators across and we just multiplied the denominators across. So if you look, just focus on the numerator, 8 times 12, we are going to prime out 8. So when you prime 8 out, it comes out to be 2 times 2 times 2. When you prime 12 out, it comes to 2 times 2 times 3, which is really important that you understand what that means when I say that, because if you haven't watched the video, you probably don't understand what that means, so it's really important. 15 primed out is 3 times 5, 14 primed out is 2 times 7. So we have all of our prime factors in the numerator, we have all of our prime factors in the denominator. What we need to do now is cancel out our common factors. So we have 2 over 2, which is 1 over 1 actually, because anything over itself is 1. And then we also have a 3 that's in common in the numerator that's in common with the denominator, so we can cancel them out. We don't have any 5s in common, we don't have any 7s. So we just have what is left. Whatever is left, we just multiply. 2 times 2 times 2 times 2 is 16. 5 times 7 is 35. We've reduced that to its simplest form. B is the same philosophy, but we have 2 negatives. We have 2 negatives. So we have negative 12 over 24 times a negative 2 over 13. Well, whenever you have a negative and you times it by a negative, it's just going to be a positive. So our answer is going to be positive. Okay, so we have 12 times 2 in our numerator, 24 times 13 in our denominator. Let's go ahead and prime them out so we can do our canceling of our common factors. 12 primed out is 2 times 2 times 3. Then we're left with the 2 times 2 in the numerator. 24 primed out is 2 times 2 times 2 times 3. That's 24 primed out, and then we have 13 times 13, so that's going to kind of stand on its own. To get to the answer, and I do not have the answer in there because I would like you to try to figure out in your head what it is first before I tell you. So in the numerator we have 1 times 1 times 1 times 1. So ultimately what will be your numerator? The denominator is 1 times 1 times 1 times 1 times 13. What will be your denominator? So think about that. If you said 1 over 13, then your answer is correct. And it's a positive answer. Okay, so here we have a fraction that we're multiplying, but we're just putting in variables that have exponents into the mix. So we just really do the same thing. We're really only just doing the same thing that we do in a fraction, and that's basically just multiplying the numerators and multiplying the denominators. We're just doing it in a little bit more of a fancier fashion here because we're dealing with exponents and variables. Okay, so let's just take everything that we have and put in the numerator that we need to multiply. We need to multiply 3 times x to the 6th power. 14 primed out is 2 times 7, and then of course we can't forget about the times x squared. Great. So we have that in our numerator. In our denominator, the only thing we really have is 7 times 1. Okay, so let's see if we can cancel anything in our numerator that we have in our denominator, and it looks like the only thing that we really have that's the same are the 7s. We're going to say 7 over 7 is 1, so we're going to cancel the 7s out. We're basically left in the numerator numeric 3 times 2, which is 6. Now if you remember the exponential rule, as long as your bases are the same, you can add your exponents. X to the 6th power and x to the 2 power, or x squared, your bases are the same. So you can add your exponents. X to the 6th plus 2. In the denominator, we're left with 1. We don't even have to write a denominator here. It's just assumed that it's 1, but we're just going to put it over 1 for the purposes of this instruction. So we're left with 6x to the 6th plus 2, or the 8th power, as our answer. Okay, and just looking at your 5.1 exercise, that looks like it would be similar to number 5 because you're multiplying fractions that have exponents. So when you're working on number 5 and 5.1, please refer to that last slide. Okay, so now we're going to be kind of focusing on dividing of fractional expressions, and there is an extra step in division that you do when you're dividing fractions. You are not really dividing anything when you're dividing fractions. You're basically still multiplying. But because we're given the division symbol, we do have to do something to our second fraction, and that's called inverting it. Sometimes you'll see the word invert, sometimes you'll see the word reciprocal. Both of them mean you're just taking something and you're flipping it. So as an example for a over negative y. When something is asking you to find the reciprocal, you're just flipping it. So negative y is in the denominator right now. You're just going to flip it so it becomes the numerator. And your answer is a negative y over a. That's really inverting the fraction or finding the reciprocal, whichever way you want to say it. When you're given the number 4 as a whole number, it's always assumed every whole number is over 1. So we keep that in the back of our minds when we're dividing fractions, and multiplying for that matter, but for dividing fractions especially, because if we need to invert or flip that fraction, we always need to remember that it's actually over 1. So when we do go ahead and invert it or flip it, then that 1 becomes a numerator. It's going to change the whole concept. It means something completely different. 4 over 1 is actually 4. 1 over 4 is actually a decimal. So they're completely different. So just remember, 4, finding the reciprocal, is actually 1 over 4. The rule for dividing fractions: when you divide two fractions, you leave the first one alone. You don't touch the first one, you just bring it down, and that's it. You can't do anything with the first fraction. But what we do is we look at the second fraction, because that's the fraction that we have to flip or invert or find its reciprocal. All three of those things actually mean the same thing. And we do that with the second fraction, and then we just multiply, just like we multiply any other fractions. So here we have an example, negative 7 over 8 divided by 5 over 13. And this is similar to number 6 and 7 in your homework assignment, so refer to this in 5.1. Okay, so like I said, you do not do anything with the first fraction, you bring it over. So negative 7 over 8, we leave it. But what we do is we change the division symbol to a multiplication symbol. Always, always, always. Please do not forget that, because we're not really dividing. Then what we do is we invert, or we find the reciprocal of the second fraction. So if we originally started with 5 over 13, it's going to flip. 13 is going to become the numerator, 5 is going to become the denominator, and then we do the multiplying, which is multiplying the denominators, multiplying the numerators. So here we have 7 times 13, and we don't forget about that negative symbol there. Since there's only one negative fraction, we're going to put that negative symbol before our work. Okay, so numerator 7 times 13, denominator 8 times 5. There are no common factors there, so basically what we have to do is just multiply straight across. 7 times 13 is 91, 8 times 5 is 40. So negative 91 over 40 is our answer to that division problem. We're going to leave it in the improper fraction format for now. Okay, so this one is very similar to number 8, and it is division of fraction, because there is a division symbol there separating the two fractions. Now, I have to say there's not a parentheses in your exercise, but just to note, 5.1 is division. It looks like a plus sign, but it is definitely division. So when we, the reason why the parentheses are in the second fraction is to actually separate the negative symbol before the 42 and the division symbol in the problem. Hi, I was just doing a podcast.
You meant to come back?
Do you know how to pause it? Can you pause it when you're doing a podcast? Okay, sorry about that little pause there. So here we have 9x to the 6th power times 18x to the 4th power, and that is our numerator. Let's put them together in the numerator, and then we'll go from there. 21 times a negative 42. Okay, so we're going to put that, there's only one negative that we're dealing with. We have a negative fraction times a positive fraction. So we're just going to put that negative symbol before all of our work so it doesn't get in the way. Okay, so then we're going to take 21 and we're going to times that by 42 in our denominator. So we're going to do prime factoring for our numbers here. So 9 is 3 times 3. And we'll leave x to the 6th power. We won't actually spell out the x times x times x times x times x times x 6 times. We'll just leave it in its exponential form. 18 is prime factored is 9 times 2. 9 factored is 3 times 3. So that's actually 2 times 3 times 3, because if you take 2 times 3 is 6 times 3 is 18. So prime factored is 2 times 3 times 3 times x to the 4th power. Okay, so in the denominator, 21 prime factored is 3 times 7. 42 prime factored is 2 times 3 times 7. Okay, so we have all of our prime factors. So what we're going to do now is we're going to start canceling out our common factors, top and bottom. All right, so we have 2 3's in our denominator. We have 2 3's in our numerator. We have a 2 in our numerator and a 2 in our denominator. We can cancel them out. We are left with x to the 6th power times 3 times 3 times x to the 4th power in our numerator. And that comes out to 3 times 3 is 9. X to the 6th times x to the 4th power. When you have the same base, which we do, which is x, we just add our exponents, which is 6 plus 4. As long as they're on the same, as long as they're on in the numerator together. The denominator, we don't have any exponents. We just have numbers left, and that's 7 times 7, and that comes out to 49. We can't forget about bringing that negative symbol over. So our answer is negative 9x to the 10th power over 49. Okay, so here is a division problem where we have to take the second fraction and flip it. So our first fraction is actually by itself. It's just a term without a denominator. So we're going to make 1 the denominator. So we have 28x to the 5th power, and that's going to be placed over 1. And then what we do is we flip our second fraction, which is 19 over 4x. So remember, 4x used to be our numerator, now it's our denominator. So we're just going to multiply across. 28x to the 5th power times 19 is our numerator. 1 times 4x in our denominator. So we're going to prime factor 28 out, which is 2 times 2 times 7. X to the 5th power times 19. 19 can't be prime factored out because it's already a prime. Our denominator primed out is 1 times 4, primed out is 2 times 2, and then we're left with the x. Okay, so here we're going to cancel out our common factors between numerator and denominator, which is 2 over 2 and 2 over 2. That leaves us with 7 times 19, and then our numerator times x to the 5th power. So 7 times 19 happens to be 133. We're left with x to the 5th power. So then in the bottom we have x and times 1, which is actually x to the 1 power. Any variables by itself, it's always assumed that 1 is the exponent. So here, remember, the exponential rule is if your exponent is less, if you have the same basis, first of all, in a fraction, and your exponent is larger in the numerator, you're going to actually take that exponent in the numerator and subtract it from the 1 in the denominator. So you're left with 133x to the 4 power. Okay, so here we're moving on to our next homework assignment, which is 5.2. We're still in chapter 5. We're just working on the next section, which is 5.2, least common multiples. Alright, so when you think of multiples, you think of numbers that are more than the actual number. When you think of factors, you think of numbers that are actually less. So a lot of students get confused between factors and multiples. So I would suggest to study them both and know the difference between the two. However, multiples of 12x and 20x are, you're just taking that term, you're multiplying it by 1, 2, 3, 4, 5, and so on. It just so happened that they stop at 5 here. So 12 times 1, 12x times 1 is 12x. 12x times 2 is 24x. 12x times 3 is 36x. 12x times 4 is 48x. 12x times 5 is 60x. On and on and on. Since it only asks for the first 5, we're only given the first 5. 20x, I'm going to take that term and times it by 1, 2, 3, 4, 5. So 20x times 1 is 20x, 20x times 2 is 40x, 20x times 3 is 60x, 20x times 4 is 80x, and 20x times 5 is 100x. When you see the acronym LCM, that means least common multiple. And least common multiples are basically you're taking a number and you're multiplying it by 1, 2, 3, 4, and so on, and so on, and so on. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24. We're going to do the same thing with 5. We're going to find the multiples of 5, 5, 10, 15, 20. So we're going to look to see in our two groups here of multiples. When you think of LCM, okay, M stands for multiples. So what we're doing here is we're finding multiples. The next thing we want to do is we want to look for common multiples. So basically that's just the same number in each one of those groups. Okay, so let's look at the numbers and see if we can find 2 that are common. Yes, we found 20. Least is basically, okay, well, are there any common multiples less than 20? No. So 20 is our least common multiple of 4 and 5. So if you need to watch this a few times to get the hang of what an LCM is, please feel free to do so. Here we have prime factorization. And I know you've watched that video already, so that's good. Since you've watched that video and you've really got a good education on prime factorization, or sometimes they call it the factor tree. And they call it the factor tree because it branches out, just like a tree has branches, and then the numbers off the branches are like the leaves. So 28 is like the tree stump. The 2 lines connecting from 28 are like the tree branches, and then 7 and 4 are like the leaves. So that's kind of why they call it a factor tree. Here we want to find the LCM of 28, 36, and 70. So we're going to list the number 28, we're going to list the number 36, and we're going to list the number 70. Okay. Well, I mean, we could find the multiples of all 3 numbers, so we could be sitting here for a half an hour, 45 minutes. So I'm going to show you a shortcut on how to find them. The least common multiple of those 3 numbers is a shortcut. And by doing that, the first thing that you have to do is find the prime factors of all 3 numbers. So 28, 2 numbers multiplied together to get 28, 7 and 4. We are circling 7 because it's a prime. We can't go any further. There are no 2 numbers multiplied together to get 7 other than 7 and 1. So we're going to circle that number because we're going to need that number inside the circle later on. 4 is a composite number because there are 2 numbers you can multiply together to get 4 other than 4 and 1, and that is 2 times 2. We are going to circle 2 times 2, 2 and 2, because they're both prime. Okay, let's move on to 36. 2 numbers multiplied together to get 36, 4 and 9. 4 times 9 is 36. They both happen to be composite numbers because 2 numbers multiplied together to get 4, 2 and 2, and 2 numbers multiplied together to get 9, besides 9 and 1 are 3 and 3. Okay, so we circle 2, we circle 2, we circle 3, we circle 3 because they're prime numbers. Okay, so we'll move on to 70. 72 numbers multiplied together are 7 and 10. We can circle 7 because 7 is a prime. 10 is a composite, we can continue. 2 numbers multiplied together to get 10 are 2 and 5. We're circling 2 and 5 because they're prime. So now that we've circled them, you might want to use red ink because so it stands out if you're doing this in your notes. Now that we have them circled, we're going to list them. Well, this is probably the easiest thing to do in finding the least common multiples. It's basically just listing them because you did all the work finding them. So now we just have to list them. Okay, so the prime numbers for 28 are 2 times 2 times 7. The prime numbers for 36, we look to see what we have circled, 2 times 2 times 3 times 3. We have 70, and the prime numbers for 70 are 2 times 5 times 5. Now remember why they're called prime, because they're prime numbers. There are no other numbers besides itself and 1 you can multiply together to get it. So we have the prime numbers listed. So we did everything that we need to do. in the first part of finding the LCM. Now I'm going to give you step 2. Step 2 is now we have to find the least common multiple. We're going to take our first multiples of 28 and we're just going to bring them down. 2 times 2 times 7. We're going to use them. Okay, so that's where we're starting out. Now, then what we're going to do is look at our primes for 36. We're going to kind of break it down intricately, and we're going to say, okay, we need to look at each one of those primes and see if they're already included. Do we have a 2 in our list? Yes, we already have a 2, because we only have 2 times 2 times 7 right now. Just ignore 3 times 3 times 5. Put your fingers over there, over them for right now, because we're only working with 2 times 2 times 7 in the least common multiple, because that's 28. Alright, so we're looking at 36. Do we have a 2? Yes. Do we have 2 2s? Yes, we have 2 2s already. Do we have a 3? No. We're going to put a 3 down. Do we have 2 3s? No. We're going to add another 3. Good. We did 28, we did 36, we can cross them off. We're now looking at 70. Do we have a 2 in our pile? Yeah. Do we have a 5? No. We're going to add a 5. Do we have a 7? Yes, we already have a 7. Here we are. So we have LCM. 2 times 2 times 7 times 3 times 3 times 5. And that comes out to, when you multiply them, 1,260. So the least common multiple of 28, 36, and 70. Okay, so here we're finding the least common multiple of 4x, x squared, and 10x. Okay, so let's list all of our terms. So we have 4x, we're going to list that. We're going to list x squared, and then we're going to list 10x. First thing we want to do is we want to find the least common multiple of 4x. Well, 4 factored out is 2 times 2. You can't really factor x out, it's just x. X squared factored out is x times x, and 10x is 2 times 5 equals 10, and then we're left with the x. Okay, so that's the first part of finding the least common multiple. We're going to go to the second part now. The second part is when we list our least common multiples to actually find the answer. So we're going to take what we have for 4x and just put that in our pile. 2 times 2 times x, so we're just going to use that. Great, we're going to cross that off. Now we're going to go to x squared. We're going to take a look at the first x. Do we have an x already? Yes. Do we have 2 x's? No. So let's add a second x. Good. Let's go down to 10x and look at the primes there and see what we need to place in our least common multiples. So do we have a 2? Yes. Do we have a 5? No. Let's put in a 5. Do we have an x? Yes, we already have an x. Great. Our least common multiple is 2 times 2 times x times x times 5. When you multiply that all out, it comes to 20x squared. Okay, so if you look on your homework assignment on 5.2, and we have 10y to the third power and 25y to the second. This is actually number 8, so I want to give you the answer on this and help you get through that, because this one is probably the most difficult one to work on here. So the first thing that we want to do before we do anything else is we have to list our terms. 10y to the third and 25y squared. Great. So we want to find the least common multiples of both of them. So 10 factored out is 5 times 2. Y cubed factored out is y times y times y. Great. We found the primes for 10y to the third. Let's find the primes for 25y squared. 25 is 5 times 5 and their prime. Y squared is y times y. Great. So we finished number 1. Let's go to number 2. What we want to do is find the least common multiple by taking into consideration that all primes are accounted for in your answer. So we're going to start out by looking at the prime for 10y to the third power. Okay. We're going to just bring down all of them. 5 times 2 times y times y times y. And then we're going to start out with that, and then we're going to add the ones that we don't already have. Let's look at the second term, which is 25y squared. There is a 5. We already have a 5 in our red list. Let's look at the second prime. There's another 5. Do we have a 5 in our original list? No. Down at the bottom, we're going to add that extra 5. Do we need to add another 5 in our list? Yes, so now we have 2 5s. Okay, so let's look at 25y squared, and then we have a y. Do we already have a y? Yes, we already have a y in our red list. Do we have another second y? Yes, we already have a second y in our red list. So we don't need to add any more y's in our LCM. So our least common multiple is 5 times 5 times 2 times y times y times y. When you multiply them, that comes out to 50y to the third power. This is going to come in handy when we start doing addition and subtraction of fractions, because a lot of times when we have to find the common denominator for fractions, the numbers are large or we're working with variables that have exponents. Sometimes it can be complex. So please, if you have to look at this slide over and over again, it will help you with the subtraction and addition of fractions that we're doing in the next section.